Alright, so today we are going to be talking about orbital diagram. Before we get into it, I want to review our electron configuration and our noble gas configuration because those are both going to be important for our orbital diagrams. For our full electron configuration, I used magnesium as an example here, and magnesium has a total of 12 electrons. So we want to describe all 12 of those electrons, starting at our first orbital, 1s2, 2s2, 2p6, 3s2. And you can add them up. 2 plus 2, 4, plus 6, 10, plus 2, 12. Get them all 12 electrons, okay? If we want to do our noble gas configuration for that, what we're going to do, we go back to our last noble gas, which is neon, and then finish up from there, 3s2. Okay, so this is the noble gas configuration for neon, which is represented just by neon in brackets. Okay, so what we want to do when we're doing our orbital diagrams is we're going to need this full electron configuration to help us out. Okay, we're going to need that. So if you look over here, this is an example of an orbital diagram for magnesium. You can see I've got these boxes. Okay, those are going to represent the orbitals. So boxes represent the orbitals. And then the arrows are going to represent your electrons. So each arrow represents electrons. So if I have a pair of arrows, I've got 2 electrons. And we'll talk a little bit about why they look funny and not like a normal arrow, okay, in a little bit. And you'll notice underneath I've got each subshell labeled. So this box represents the 1s orbital, this box represents the 2s orbital, this group of 3 boxes that looks a little bit like a train car represents the 2p orbital, and then this box represents the 3s orbital. And you'll notice if you look through, you can count the electrons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 electrons. You can physically see all 12 electrons described by mg. Okay, so let's take a little bit of a closer look. Alright, so we've learned about 2 things already. We know that our orbitals are represented by boxes and that our arrows are representing electrons. Okay, so our s orbital only can fit 2 electrons, so it just needs to be a singular box that'll have 2 electrons in there, maximum. Okay, our p orbital is actually going to be 3 boxes all connected together, and it's important that they are connected together, okay, like this, and show that 3, because a p orbital can hold 6 electrons, and I'll draw those in a little bit. A d orbital can hold 10 electrons. Remember that d orbital over here, there are 10 rows across, right? 2 over here, 6 electrons here, 6 electrons here in your p orbital. Okay, so our d is going to have 5 boxes holding 2 electrons each. Okay, again, that's a little bit like a large bus. Okay, 1, 2, 3, 4, 5 boxes. Our f orbital, if that holds 14 electrons, take a wild guess. How many boxes? Divide by 2. That's right, you're going to use 7 boxes for that. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so your s orbital holds 2 electrons, p holds 6, d holds 10, f holds 14. And you're going to need to use 1 box, 3 adjoining boxes, 5 adjoining boxes, or 7 adjoining boxes to describe that. So you guys will notice I'm going to be filling in my electrons. Okay, so I can get 6 electrons in there, okay, into a p orbital. Same thing holds true for each. Each individual compartment can hold 2 electrons. Before we do an example together, what I'm going to do is I'm going to describe these arrows. So we've got arrows. We've got 1 up and 1 down. This is called spin. This is called spin. And basically what happens is these electrons, when they're going around in these orbitals, they don't want to be near each other because they're 2 negatives. 2 negatives will push apart from each other. They'll repel. Okay, and opposite, right? Opposites attract. 2 negatives will repel from each other. So when they're in these orbitals, think about one going one direction and the other is going the other direction. They are opposite spinning. Okay, it's a little A little hard to do with my hands, right? But they're going to spinning in different directions, okay? So that's why we draw one spin up and one spin down in each box. The other thing to know, like for my p orbital, so I'm just going to draw a p orbital up here, okay? You're going to have 6 electrons in there, and they're each going to fill their own compartment before they join up with someone else. Okay. So 1, 2, 3, and then you pair them up, 4, 5, 6. Okay, so if you only had 4 electrons, you would have a p orbital that had 1 in each box. 1, 2, 3, 4, and that would be 4. Okay, so 1, 2, 3, 4. You would not, so I'm drawing a bad example right now, so write bad next to it. You would not do this, because then, let me switch colors. You do not do this. Bad. Okay, then what happens is that you have this empty orbital, and then you have electrons that are just way too close. Okay, it's just like if you guys were going to take a seat on the T or on the bus. If you were walking on and you didn't know anyone on the bus and there were some seats open and some seats already taken, you're going to take a seat that's already open. You're not going to sit right next to somebody. You're going to spread out. And the electrons want to do the same thing. Okay, so think about those electrons filling seats of a bus. They're going to spread out first before they have to sit next to someone in a little pair next to them. Okay, so let's do an example now. All right, so we've got our periodic table here for help, and what we're going to do an example of phosphorus. Oh, let's try one a little bit harder. Let's do one with a d orbital. Let's do titanium. Ti. We've got 1 s, 2 s, 2 p, 6, 3 s, 2, 3 p, 6, 4 s, 2, 3d, make sure you remember it's 3d, and then it's actually going to be 3d too. Okay, so what we're going to do for this one is we have to draw all of these out. I don't think I'm going to be able, actually maybe I'll put it on the bottom so you guys can see it all in one line. So let me move this periodic table a little bit. All right, so we've got our periodic table and we're going to just straight across. So I've got 1s2, I'm going to draw an s orbital. I'll label it 1s. I've got my 2s, so another box. 2s, I've got a 2p. Draw my 3 cars all together. 2p. And you'll notice that I'm labeling each one underneath it. I've got my 3s, and then I've got my 3p. My 3p, and you guys will notice that you'll find it hard to start making these sizes, but you'll get used to it, okay? So it might be hard to know how much you need to draw to get that 3 compartment. That's fine. I've got my 4s, and then my last one is my 3d, and that's going to be 5 boxes, so this is going to be pretty big. 1, 2, 3, 4, 5. Okay, so that's going to be my 3d. So now you guys can see I've got my 1s, my 2s, my 2p, my 3s, my 3p, my 4s, and my 3d. So I've got all of these orbitals taken care of. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to switch colors so you guys can start to see the electrons that I'm putting in there, okay? Get my electrons out. All right, so for each of these, I'm going to draw in how many electrons there are. 1s has 2 electrons, so 1 up, 1 down. 2s, also 2 electrons, 1 up, 1 down. And you'll notice all my electron orbitals are filled before I moved on to my next orbital. So I've got my 2p, I've got 1, 2, 3, 4, 5, 6. And it's good to get in a habit of filling 1 in each box before you double them up. 3s, one up, one down, 3p, another 6. We're going to fill them all the way up. You want to make sure you fill in all the spins in the same direction first before you make opposite spins as well. So that's another thing to think about. I'll show you an example of, this is a bad example right here. If you did this, right, because they're not all spinning in the same direction, so that is no good. You want to get them all spinning in the same direction first. So let's fill in my 4s, one up, one down, and then my 3D, I only have 2 electrons, so I'll put one in the first box and one in the second box. You never want to start over here. It's fine if you have some extra ones, but you want to fill your first 2 boxes, put one in each box first before you double them up. And you don't want to, start out with an empty orbital. Fill those first orbitals first, okay? So that's a great example of an orbital diagram, and next I'm going to have you try a couple on your own. All right, so just give it a whirl. I'm going to give you 2 ones to try. All right, so here's what I want you to do. I want you to try these 2 practice problems. I want you to try fluorine first, and then I want you to try phosphorus second. Please use your periodic table to help you. Start by writing your full electron configuration all the way out, your 1s2, your 2s2, okay? And then make your orbital diagram, which is basically just a picture representation of your full electron configuration. All right, so try these 2. I want to see them in your notebook when I see you in class today. All right, have a good one. Bye.